Chemistry powers progress and binds us all together. But there's something more that sets us apart. Courageous chemistry.
Hello and welcome to today's lesson. In today's lesson, we'll look at types of reactions, and then we'll look at oxidation and reduction reaction. Of course, I'm talking about chemical reactions. You already know from your first senior level that we have different types of reactions, such as a combination or synthesis. We have decomposition. Let's begin with synthesis, or what is called combination. In synthesis or combination, you simply add two elements or molecules together to form a compound. Okay, in this case we have hydrogen and what? Chlorine. Both molecules are said to be what? Diatomic. Why? Because they contain more than one atom that are joined together. Is it not? Yes. The reverse of this kind of reaction is what we call decomposition reaction. In decomposition reaction, you have a compound breaking into what? Simpler molecules or compound. In this case, we have hydrochloric acid breaking down to give us what? Hydrogen and chlorine. Then we have, of course, single or replacement reaction. And replacement reaction is of two kinds: single replacement and double replacement. In single replacement, you simply have the replacement of an ion. As you can see here, ion is replacing copper in this reaction. They also have double displacement reaction. It's like single displacement reaction, but in this case here you have sodium nitrate or silver nitrate combining with potassium chloride. The silver will now bond with the chlorine, while the potassium will now bond with the what? Nitrate ion. So there is exchange of two different ions to form two different what? Substances. In combustion reaction, we are burning a substance in oxygen. The key to understanding combustion reaction is that oxygen must be involved, and then two major products are formed in combustion reaction. They are carbon dioxide and water. Take note of that. Okay, take note that every combustion reaction must involve oxygen. All right, and then the two products must always be carbon dioxide and water. Okay. Another type of reaction is called neutralization reaction, which is called acid-base neutralization. In this case, an acid combined with a base to form salt and water. Or you can simply say when hydronium ion combine with hydroxide ion to form what? Water. Hydronium ion, I mean H3O plus. Hydroxide ion, I mean OH minus. Okay, to form water. We call it a neutralization reaction. So know the product: salt and what? Water. Now let's look at oxidation and reduction reaction. It is also called redox reaction. Why? Because it is a complementary process which occur simultaneously. That is, as one species is being oxidized, the other species is being what? Reduced. Okay, there are three main ways we define redox reaction. We define redox reaction in terms of oxygen, in terms of hydrogen, and then in terms of electron transfer. In terms of oxygen, we say oxidation is the gain of oxygen in a species. Okay, when a species gains oxygen, we say that species has undergo oxidation, while reduction, of the other hand, will not be the loss of oxygen in a species. So when a species loses oxygen in reaction, we say that species has undergo reduction. Here's a typical example. I have magnesium reacting with what? Water to give me magnesium oxide plus what? Hydrogen gas. In the reaction above, magnesium has been what? Oxidized. Why? Because magnesium has now gained oxygen to form magnesium oxide. Why water molecule here has been reduced? Why? Because water molecule has lost the oxygen and it has been reduced to what? Hydrogen what? Gas. So you see that redox reaction is a two-way reaction that is occurring simultaneously. Is it not? Yes. All right. So here magnesium is what? Oxidized, and then hydrogen water molecule is what? Reduced. Is it not? Magnesium is oxidized to magnesium oxide, while water molecule is what? Reduced to what? Hydrogen gas. So I'm going to talk more on that. Okay. Now let's look at the definition in terms of hydrogen. In terms of hydrogen, we define oxidation as either the loss of hydrogen or simply the removal of what? Hydrogen. Take it again. Oxidation is defined as either the loss of hydrogen or removal of what? Hydrogen. While reduction on the other hand will not be the gain of hydrogen or the addition of what? Hydrogen in a species. Look at this reaction now. We have hydrogen sulfide combining with what? Chlorine to give us 2 moles of hydrogen chloride plus what? Sulfur. In this reaction now, who is losing hydrogen? Hydrogen sulfide, is it not? Hydrogen sulfide has lost these 2 molecules of hydrogen to become what? Sulfur. So we say here that hydrogen sulfide, okay, is what? Oxidized to sulfur. Why? Because it has lost what? The 2 molecules of what? Hydrogen, is it not? To what? To the chlorine atom. Now you can see that it is now what? Sulfur at the product end. Now let's take a further look at chlorine. Chlorine is now having the what? Hydrogen, is it not? Yes. So we say chlorine is what? Reduced to what? Hydrogen chloride. Why? Because it gained hydrogen. So take note the definition of this reaction in terms of what? Hydrogen. Let's now look at the definition of redox reaction in terms of electron transfer. Okay, in terms of electron transfer, we define oxidation as the loss of electron, while we define reduction as the gain of electron. Okay, most reaction processes such as photosynthesis, combustion reaction, neutralization reaction are all examples of redox reaction. Okay, this is a typical example. Now A is transferring electron to what? B. Because A is transferring electron to B, we say A is undergoing oxidation. Okay, and then we say that A is oxidized. On the other hand, B is accepting electrons, so we say B is undergoing reduction, or we say B is what? Reduced. Okay, why do we use the term oxidation to be loss of electron and then reduction to be gain of electron? It has to do with their oxidation number. Okay, generally when something starts to lose electron, its oxidation number will increase. Okay, while when something starts to gain electron, its oxidation number will decrease. Try to understand it. You can pause it and take it again. So use the acronym OIRIG to remember the definition. Oxidation is loss of electron. RIG, reduction, is gain of what? Electron. All right, oxidation leads to increase in oxidation number. Reduction leads to what? Decrease in oxidation number. Another acronym is LEO, the lion says gear, is it not? LEO, loss of electron is oxidation. Gear, gain of electron is what? Reduction. Okay, depending on which acronym you can use. All right, now let's take a look at a typical example. Okay, in this reaction we have sodium combining with what? Chlorine to form sodium chloride. Of course, this is an example of synthesis, or what we call combination what? Reaction. Let's begin to break down what is actually taking place here. We have an ionic bond there, is it not? Or what we call electrovalent compound. We have sodium and being the positively charged atom, while chlorine being the negatively charged atom. But this is not the initial beginning. Okay, let's go back to the beginning. At the initial start, we add a neutral atom, sodium and what? Chlorine. So both of them are neutral, but they are coming together means that there must be transfer of what? Electron. So sodium donates the electron that it has in its atmosphere to form a sodium plus ion, because it is now one electron what? Deficient. On the other hand, chlorine accepts this one electron to become what? One extra charge, having deficiency of the what? Positive, is it not? Yes. So we now have the positive and the negative bonding together to form the sodium chloride compound, is it not? Yes. So we write this as sodium plus chlorine to give us sodium chloride. We will represent this ionically. We have sodium neutral giving us sodium ion plus an electron, and then we have chlorine neutral accepting that electron to give us chlorine what? Negative. So you see the difference in oxidation number here, meaning sodium is oxidized while chlorine is what? Reduced, is it not? Yes. So how do we represent this in an equation? We use a line to draw it here. As you see here, we now see that sodium Neutral to give us what? Sodium ion. We say it has undergo what? Oxidation. Alright? Why? On the other hand, chlorine, neutral to give us chlorine negative charge, we say it has undergo what? Reduction, which is what? Gain of what? Electron. So oxidation, loss of electron, reduction, gain of what? Electron. In this process, we say sodium is what? Oxidized, and chlorine is what? Reduced. And we call this oxidation reaction and reduction reaction separate reaction. We call it half reaction. What do I call it? Half reaction. Okay, you can see the half reaction for oxidation, and you can see the half reaction for what? Reduction. Remember we earlier said oxidation leads to increase in oxidation number, is it not? Or what we call oxidation state. While reduction leads to what? Decrease in what? Oxidation number or oxidation what? State. Let's look at an example. Here you have copper combining with silver to give us copper 2 plus 2 moles of silver. Okay, here you see that copper oxidation state is changing from 0 to +2. So we say copper is undergoing what? Oxidation. Why? Because its oxidation number is changing from 0 to +2. That means it's the one actually donating what? Electron. While on the other hand, you see that silver oxidation state is changing from +1 to 0. Is it not? It's decreasing from +1 to what? 0. So we say silver is undergoing what? Reduction, because it's actually gaining what? Electron. In sentence, we say copper is oxidized to copper 2 ion. Is it not? Which is from 0 to +2. On the other hand, silver is reduced from silver ion to what? Silver, that is from +1 to what? 0. Alright, I believe you understand. What are oxidizing and reducing agents? An oxidizing agent accepts electron, oxidizes other substances. Its oxidation number will decrease, and it will also be what? Reduced in the what? Reaction. On the other hand, a reducing agent reduces other substances, donates electron, and its oxidation number will what? Increase, and also it is oxidized in the what? Reaction. Let's take an example. In this reaction, we have zinc oxide combining with carbon to give me zinc solid and carbon 2 oxide or carbon monoxide. Now, my oxidizing and my reducing agent would be at the reactant side. Take note of that. It can never be on the product side. But my oxidation half reaction will be carbon to carbon monoxide. Why? Because it's gaining what? Oxygen. While my reduction reaction will be zinc oxide to what? Zinc. Now, talking about reducing agent, we say reducing agent is a substance that donates electrons, is it not? And it becomes oxidized, and its oxidation number also what? Increase, is it not? Yes. So my carbon here is my reducing agent. Why? Zinc oxide is now my what? Oxidizing agent, because the oxygen will accept the electron, the zinc oxide will become reduced, and the oxidation number of zinc will also what? Reduce, is it not? Yes. So carbon, the reducing agent, is oxidized. Zinc oxide, the oxidizing agent, is reduced. Okay? And then what again? The oxidation number of zinc will decrease, while that of carbon what? Increase. Here are some examples of oxidizing and reducing what? Agent. What you should know here is that generally substance that accept electron are oxidizing agent, or tends to be oxidizing agent, while those that donate electron tends to be what? Reducing agent. That now brings us to the end of today's lesson. Do your other activities in this class. See you. Bye.